Hello everybody, welcome back to the workshop. So in this video, it's time to answer some more of your questions in this episode of Blacksmith Question of the Day. So first off, thank you for watching, and let's hop right into it. First question of the day comes from Granddad's Forge, and he used the proper hashtag. I'm proud of you, sir. Thank you so much. He said hashtag question of the day. I've gotten rid of scale with vinegar bath. Will that work on plasma scale? And that question came in on the video of anneal it first. So great question. The vinegar bath will not get rid of the plasma scale. In fact, there's a commenter that corrected me down in the comment section of this video and said that that is actually considered dross, or they call it dross, the little dangly bits that hang off on the bottom side. That's actually liquefied metal. It is not scale. Now, the actual carburized edge from the flame burning through it, or the arc, or whatever you're using as far as a plasma cutter or something like that, it won't get rid of that either. It will get rid of mill scale, it will get rid of scale that's from forging heats and things like that, but it won't get rid of that hardened layer right around the edge. That's why we have to anneal it, bring it up to a good heat. Now, a great practice would be to take and anneal the pieces and then soak them in a bucket. If you've got the time and you've got multiple pieces, is to anneal the pieces first, then soak them out, and after they've cooled down, soak them in a bucket of vinegar and just leave them there for a few days so this way it can do its magic, and then rinse them real good and then go ahead and start filing from there. That will help you get really soft steel to work with. Now, if you want to exclude that last, the step of the pickling, you don't really have to do that if you're just working on the edge, because annealing will help break up some of that on the edge anyhow, so it'll go much better for you. So great question, thank you for asking it, and let's move on to the next one. Next question. This next question came in, and it's a bit more of a satire comment, more or question than it is a good opinion, a good question anyhow. But it came in on our sharp edges video, where I talked about why I like sharp edges on my anvil versus having these big giant radiuses. Anyways, it came in from Zipperneck, and he asked, "Have you always been this opinionated?" ? So to answer you, Zipperneck, yes, I have. It's just kind of my biological makeup. I'm a very opinionated person. That doesn't mean my opinions are always right or correct or accurate, but they are my opinions. Just like anybody else on the face of this globe, we all have opinions. What do they say? I can't repeat it on YouTube, otherwise I'll get demonetized. I've heard a lot of different analogies, the ones with the armpits and a bunch of other ones. I'll keep it PG and Christ-centered on this channel, but you can fill in the blanks. Please don't do so in the comment section down below. But anyways, yeah. So I've always been opinionated, and that probably will likely not change in my next 100 years or so. Next question comes from Jerome. I don't even know how to pronounce your last name. Excuse me. Apologize. So I'm not going to go with that. You guys can see it on screen there. Anyways, he used the proper hashtag. Great. I appreciate that. Hashtag question of the day. Hi. Sorry, I'm a bit new at smithing. Just wanted to ask, how can we deal with decarburization? Is it a big deal for manual knife making? I don't have fancy power hammers, and I just hand forge most of my pieces. So I heat them up more versus the mechanized smith, and it got me worried if all my pieces will fail due to decarburization. Okay, Jerome, great question. And first off, I'd like to preface this with that I am not a metallurgist. So I'm going to speak to you from a blacksmith's understanding of metallurgy, which can be very sketchy. So stick with me. All right. Most of the time when we're talking about decarburization, it is on a minute scale. And the reason for that being is that steel got hot, steel got poured into a mold at some point, rolled out through a bunch of rollers, made into a certain bar stock size, and then shipped out the door. So throughout that whole process, when they were smelting it, they were pouring it, they were rolling it out, they were putting it into sheets or bar stock or however they were going through the multiple rollers. And then it was formed. If you've got it in raw steel, it's great. But if you've gotten it in, say, a piece of scrap steel, it was hot formed into whatever it was going to be as well. It has been through a lot of different heating cycles in its life by the time it's gotten to you. And so therefore, there's always a little bit of a percentage swing when it comes to the carbon content in steels, in materials, depending on where they've come from in the world. So if it's made here in America, great. It might be of one, they might have certain standards that are really rigid or not. If it's made in China, India, who knows, wherever it's at, Timbuktu, wherever the steel's made at, otherwise, that might have been imported steel. You don't really know these things. And again, they might not have as much quality control, or they might have more. With that being said, the worry of having decarburization is kind of a moot point in my opinion. I haven't seen any tool where somebody can say, oh, well, that was decarburized by 0.01% carbon or 0.02% carbon, so we've lost that much carbon, and now this tool's not a good tool anymore. I think that type stuff really only matters if you're going to be doing machining, or if you're a machinist and like specific tools need a specific heat treatment and they need to be very accurate. And usually those tools are not forged, they are machined in of themselves too as well. So they take a blank stock and they might turn it into whatever it's going to be, and have carbide cutters and all sorts of other stuff, which we're not going to get into all that. I'm not a tool and die guy, clearly. But as far as just making a blade or making a pair of scissors or making a tool or a hot cut or a chisel or a hardy tool or something like that, decarburization is not something you really generally are going to have to concern yourself with here in the blacksmithing trade. With that also being said, leaving your material in a fire, whether it be a gas forge, a coal forge with a blower running, or constantly cranking a blower and constantly heating the material but not getting the work done, you can suffer not only some decarburization, but the more the thing that you're going to suffer from is over-oxygenating the steel and burning it. That's going to happen, and or get excessive grain growth in a piece, and that leads to more failures than, say, the decarburization of steel, if you will. I would say that it's a very negligible, unless you're spending 18 hours in the forge with one piece. Then you're probably going to see a big reduction, and then that would be something to be seriously concerned about. But other than that, I think you're perfectly safe, perfectly fine. Learn with what you got. People make knives out of coil springs and leaf springs, and those have seen the gamut of heat treatments and stuff from the factory. And again, they all have a random percentage of carbon, so it really shouldn't matter to you at all in hobby smithing. If you get into industry or tool and die work, then it will matter. But for what we do on a regular basis, probably not. So that's it for today. I hope I was checking and referencing, making sure I got all my questions right. I hope you guys enjoyed this video. If you did, hit that like, drop your question of the day using hashtag question of the day or hashtag blacksmith question of the day, and it will make it a lot easier for me to find the questions in the future. Again, just drop those down in the comment section down below, and I'll see about taking and making some more videos just like this one if you enjoyed them. That's it for today. God bless, and as always, we'll catch you on the next one. Thanks for watching.